Before we start, make sure you watch until the very end, because what you're about to hear only gets stranger the deeper we go. Imagine a world where it rains molten glass sideways at thousands of kilometers per hour, where the sky glows with an alien hue, and where standing on the surface even if you could would mean instant destruction. This isn't science fiction. This is real. Today, we're diving into one of the strangest planets ever discovered, a place so extreme that it challenges everything we thought we knew about planets and how they behave. Let's set the scene. For centuries, humanity believed our solar system was the standard blueprint for how planets should look and act. Rocky worlds close to their star, gas giants farther away, everything following a neat and predictable pattern. But once we began discovering planets beyond our solar system, so-called exoplanets, that neat picture shattered almost instantly. Among the thousands we found, a few stand out as truly bizarre, and one of the strangest of them all is a planet known as HD 189,733b. This planet orbits a star about 64 light-years away from Earth, which in cosmic terms is practically our neighborhood. But don't let the relatively short distance fool you. HD 189,733b is nothing like anything in our solar system. It belongs to a category called hot Jupiters, massive gas giants that orbit extremely close to their stars. And when we say close, we mean unbelievably close. HD 189,733b completes an entire orbit in just a little over 2 days. For comparison, Mercury, the closest planet to our Sun, takes 88 days to orbit. Because of this proximity, the planet is subjected to intense stellar radiation. Its surface, or more accurately, its upper atmosphere, its temperatures of around 1,000 degrees Celsius or more. That alone would make it inhospitable. But this is where things start to get truly bizarre. Scientists studying HD 189,733b made an incredible discovery when they analyzed the light coming from its atmosphere. The planet appears to be a deep, vivid blue. At first glance, that might sound almost beautiful, even Earth-like. After all, Earth is a blue planet, but the resemblance ends there. The reason HD 189,733b looks blue is not because of oceans or skies like ours, but because of silicate particles in its atmosphere, tiny bits of material similar to glass. And here's where it gets even more extreme. Those particles don't just float gently in the air. The planet experiences winds that can reach speeds of over 8,000 kilometers per hour. That's more than 7 times the speed of sound. These winds whip the silicate particles around the planet, effectively creating sideways rain made of molten glass. Imagine standing in a storm where shards of glass are blasting past you at hypersonic speeds. That's the reality on HD 189,733b. But the strangeness doesn't stop there, because the planet is tidally locked to its star. One side always faces the star, while the other is in perpetual darkness. This creates a dramatic temperature difference between the day side and the night side. The day side is blisteringly hot, while the night side is comparatively cooler, though still unimaginably hostile by Earth standards. The extreme temperature contrast drives those powerful winds, constantly redistributing heat around the planet. Scientists have even been able to map temperature variations across the planet's surface by observing how it emits infrared light. These observations reveal a world in constant turmoil where energy is being violently transferred from one side to the other. It's not a calm, stable environment. It's chaotic, dynamic, and utterly alien. Now, take a moment to think about how incredible it is that we can know all of this about a planet that's trillions of kilometers away. We can't see it directly in detail, and yet by analyzing tiny changes in starlight as the planet passes in front of its star, we can determine its composition, its temperature, even the color of its atmosphere. This is the power of modern astronomy. And this is a great moment to pause and say, if you're enjoying this journey into the unknown, make sure to like the video, subscribe to the channel, and turn on that notification bell so you don't miss the next exploration into the mysteries of the universe. Now, let's go even deeper, because HD 189,733b is just one example of how strange planets can be. What makes it particularly fascinating is how it challenges our assumptions. For a long time, we thought planets would fall into familiar categories, but exoplanets have shown us that nature is far more creative and far more extreme than we ever imagined. Consider the fact that on Earth, weather is driven by relatively small differences in temperature and pressure. A storm here might reach wind speeds of a few hundred kilometers per hour at most. On HD 189,733b, those differences are amplified to an almost unimaginable degree. The entire atmosphere is in a state of constant, violent motion. There are no calm days, no gentle breezes, only relentless planet-wide storms. And then there's the question of what lies beneath the atmosphere. As a gas giant, HD 189,733b doesn't have a solid surface like Earth. Instead, its atmosphere gradually transitions into deeper and deeper layers of gas, eventually reaching conditions where the pressure is so high that the gas behaves more like a liquid. If you could somehow descend into this planet, you would be crushed long before reaching any kind of surface. The pressure and temperature would simply become too extreme for any known material to withstand. But perhaps one of the most intriguing aspects of this planet is how it helps us understand the broader universe. By studying extreme worlds like HD 189,733b, scientists can test their theories about atmospheric physics, heat transfer, and planetary formation. These insights don't just apply to distant exoplanets, they also help us better understand the planets in our own solar system, and even Earth itself. For example, the study of atmospheric dynamics on hot Jupiters has led to new models that can be applied to gas giants like Jupiter and Saturn. It also helps scientists refine their techniques for detecting and analyzing smaller, potentially habitable planets. In a way, these strange, hostile worlds are paving the way for the discovery of more familiar ones. And speaking of familiar, let's address an obvious question. Could life exist on a planet like HD 189,733b? The answer, at least as far as we understand life, is almost certainly no. The extreme temperatures, crushing pressures, and violent weather make it one of the least hospitable environments imaginable. But that doesn't mean the search for life ends here. In fact, studying such extreme environments helps scientists define the boundaries of where life could exist. On Earth, we've found organisms thriving in conditions that were once thought to be impossible deep-sea hydrothermal vents, highly acidic lakes, even inside rocks miles beneath the surface. These discoveries have expanded our understanding of what life can endure. So, while HD 189,733b itself is unlikely to host life, it still plays a crucial role in the broader search for habitable worlds. As we continue to discover more exoplanets, we're finding an incredible diversity of worlds. There are planets made largely of diamond, planets with boiling oceans, planets that are slowly being torn apart by their stars. Each new discovery adds another piece to the puzzle, showing us that the universe is far more varied and surprising than we ever imagined. And yet, among all these strange worlds, HD 189,733b remains one of the most iconic, its vivid blue color, its glass storms, its extreme winds. Its extreme windsits, a perfect example of how alien a planet can be. It's a reminder that when we look out into the cosmos, we're not just seeing distant points of light. We're seeing entire worlds, each with its own unique story. Now, as we start to wrap up, I want you to think about this. Somewhere out there, beyond our current reach, there may be planets even stranger than this one. Worlds with conditions we can't yet imagine, governed by processes we don't yet understand. The more we explore, the more we realize how much there is still to discover. Before we finish, let me know what you think. Would you dare to visit a planet like this, even if you could survive for just a few seconds? Or does the idea of glass rain and supersonic winds make it a hard pass? Drop your thoughts in the comments below. I'd love to hear what you think. And if you made it this far, don't forget to like the video, subscribe to the channel, and turn on that notification bell so you never miss another deep dive into the mysteries of space. Because out there, in the vast darkness of the universe, the strangest worlds are still waiting to be discovered.